So for cycle 3, day 1, homework question 1, you're asked to find the slope, the vertical intercept, and then the equation for the relation. So to start, you would try to find the slope by 1, you can look at the graph, and you notice that you are going right by 2, so run by 2, and rise of 5. So that's one way of finding the slope. Or second, you can use the formula, which you've seen before, and you plug in your values and you find your slope. So that's part 1, question A. Part B, you'd find the vertical intercept by looking at the y-axis. So vertical intercept is the same thing as the y-intercept because vertical just means that this intercept is occurring on the vertical axis, and what vertical axis means is the y-axis. And so the y-intercept is 6. Okay? And it's always just like the value of the y value. But sometimes you might see it as a coordinate like 0, 6. Question C, it says write an equation for the relation. Okay. So in order for me to explain question 1C, it's probably the easiest if I give you a scenario, like a real world problem scenario. Even though you might think that might cause it to be harder, it might actually be easier in our case. So first off, my scenario is that it is $6 for a pan of pizza. What does that mean? It means that the y-intercept or the fixed rate that I'm paying is $6. It doesn't matter if it, on the fact that it does not have any toppings of pizza, I am paying $6 for a pizza with just like the tomato sauce, all right? And maybe we can just say that there's cheese on it. So meanwhile, let's say we start adding toppings to it. We add 1 topping, add 2 toppings, and when we add 2 toppings, we notice that it's $11. Well, what happened? Well, we calculate the slope from 1A, and we realize that it's $2.50 per topping, okay? And so this $2 per topping, what that means in the algebraic sense is that is the slope or that is the rate of change. That is how the cost that I'm paying for that pizza is changing, well, depending on the number of toppings on the pizza, right? And so I can try to make an equation for this relation. And why would that be helpful? Well, then I can know how much my pizza is if I have 10 toppings, if I have 100 toppings, if I have 5 toppings. So a lot more than the 0, 1, 2, 3 kind of example, okay? And so I have, so I'm paying, well, y equals 6. I have to pay $6, and then I have to pay $2.50 for every topping, right? And so then I have to have a let statement, and so I would say let x be the number of toppings and let y be the total cost of the pizza. So that is a real life word problem scenario that I'm creating with the graph that I'm given. And so this is how we transition to the equation. So this equation on the right, this is the general equation of a line where you have the y-intercept, which is the point where you're crossing the y-axis. And this could be anywhere, negative, 0, or positive. And then to that, we're adding the slope to it because we have a line that's not horizontal, but it is tilting, right? And so this is our equation of a line. And so if I put that into an algebraic form, well, that's how I would walk it through. So I have my y equals, well, I just put it together. I use this format, right? So my 2.5 goes here for the x and then plus 6. And then because we have that pizza example in our head, we could be kind of thinking about it out loud as, well, I'm paying $6 for the pizza and I'm paying $2.50 for every topping. But now right now I'm talking about it very algebraically. And so I would say, well, since y equals mx plus b, where y equals mx b is the equation of a line, where m is the slope and b is the y-intercept, or the y value initially starts at 6, then the slope goes up by 5 and runs by 2. So there's like 2 different ways of thinking about it. This is like the pure equation way. And I also demonstrated this way as well, because that's what you would say if you're interpreting it from the graph. You're starting off at initial value of 6, and you're going right by 2 and up by 5. Okay.